Before we start now, I want to show you how our ARKit and our ARCore are working in theory, because only when we understand the tracking, we as developer can prevent the problems which our ARKit and our ARCore still have. For this, I made a small drawing here. So roughly said, the tracking results from two aspects. On the one hand by the future points and on the other hand by the IMU. The IMU, which means initial measurement unit, stands for all the physical sensors which are in our mobile device. For example, the gyroscope. This is the sensor that detects the exact position of your device when you are moving it, for example. Then we have the future points. These special points are projected onto the camera pictures, because our recordings from our camera are nothing more than a lot of single pictures lined up in a row. That means, for example, when your game is running with 30 frames per second, then 30 single pictures are played in a row. And right on these single pictures, the algorithm projects these future points on special contrasts. You probably already noticed future points. Our ARKit and our ARCore display them with these yellow points. What happens now is following. I created another small drawing here. These two pictures should be 2 frames. And these stars should be the future points which are created by the computer vision algorithm. So for example, when the person is moving, then the future points are also moving. And now these 2 frames are compared. With this comparison, it is possible to detect the distance between position A and B. So this concept combined with the IMU allows us to make world tracking. From this point of view, there are obviously a lot of problems which I want to mention now. So first of all, the computing power is a big problem, because when you imagine that our game is running with 30 or 60 frames per second, then you can see how much power the world tracking needs. This is, by the way, the reason why our ARKit and our ARCore are only running on the newest cell phones. On older cell phones where it is possible to run augmented reality apps like Pokemon Go, there you don't have the future point aspect. They are only working with the IMU. Another big problem is excessive motion. When we move the screen too fast, we can't detect no more future points, and then we can't interact with the real world. A solution for this could be, for example, to instruct the user, don't let him to move the camera too fast. Same point for the brightness. When it's dark, we can't detect future points well. Next problem are textures. We should always point out to the user that he should use textures that have a lot of contours. Of course, when we run the augmented reality, for example, on a white surface, it is clear that we can't detect future points. And the last point which I want to mention here is it takes time to detect future points and planes. The planes are, by the way, creating by combining the future points. And as I already said, the tracking results by comparing 2 frames. Therefore, it's clear that it takes time to detect planes. On that, we maybe should inform the user before the user thinks that anything isn't working just because it takes a moment to detect future points. These are all problems where we as developer should pay attention for. So this is a rough explanation of the tracking, and how everything is working in detail we will see in the next videos.